Today we're going to learn how to differentiate other equations. So please pause the video as you go through your notes. And today we're going to learn on the sum and difference rule. So please copy these notes into your binder. If two functions f and g are differentiable, then the function f plus g, the derivative for it is the derivative of f plus the derivative of g, which means the derivative of the first term plus the derivative of the second term. And if you're subtracting the expression, then the derivative is the derivative of the first term minus the derivative of the second term. Example 1 says find the derivative of f of x, given this expression, and we want to state the domain of the original function plus the derivative. So if we're taking a look at the domain for the first function, the original of f of x, we notice that there's a square root x. So the square root x has restrictions, where x has to be greater than or equal to 0. If we take the derivative of f of x, that becomes 12x squared plus, and the root of x is x to the 1/2. So the derivative of that becomes 0.5x or 1/2 x to the negative 1/2. And since we have negative 1/2, that can get placed into the denominator as root x. So since we have a root x in the denominator, the domain of the derivative, x has to be greater than or equal to 0 as well. And if you plug either of these equations into your graphing calculator, you'll see that the x values of the graph only exists if it's greater than or equal to 0. Example 2 says find the derivative of f of x equaling x plus 2 cubed. Now there are a couple of ways that you know how to take the derivative of an expression like this. You could write out the expression x plus 2, x plus 2, x plus 2, and distribute that, and then take the derivative of the f function. So that's exactly what I've done here. You can see that I've did FOIL on x plus 2 times x plus 2, and then I distributed x plus 2 into the bracket again. Take the derivative of the expression. X cubed becomes 3x squared. 4x squared for the derivative is 8x. 4x for derivative is 4. 2x squared, the derivative is 4x. And the derivative of 8x is 8. After you combine like terms, the derivative of this expression is 3x squared plus 12x plus 12. There's also another way that you can find the derivative, and that's by doing the power rule. So the power rule, the 3 comes in front, and then you have the expression x plus 2 all squared. Well, if you do FOIL on x plus 2 squared, you get x squared plus 4x plus 4. Distribute the 3 inside the bracket, and you get the same derivative, 3x squared plus 12x plus 12. Later on, you'll be learning the chain rule. That'll be an alternative way to take the derivative of this expression. Example 3. Find the equation of the tangent line to the curve of x cubed minus 3x squared plus 6x at the point 2, 8. So if you want to find the equation of the tangent line, the first thing you need to do is take the derivative of the equation. So y prime becomes 3x squared minus 6x plus 6 And remember, finding the derivative is also the slope of the tangent line. So if it's the slope of the tangent line at the point 2, 8, you have to sub in the value of x equals 2 into the derivative. Once I sub in x equals 2 into the derivative, my slope is m equals 6. Now I need to form the equation. And the only equation formula that we're using now that we're in grade 12 is y minus y1 equals m bracket x minus x1. I'm using the point 2, 8 and my slope of 6. Simplify it into standard form where the equation is 0 equals 6x minus y minus 4. Example 4. Find the equations of the tangent lines parallel to the parabola y equals x squared minus x that passes through the point 3, 3. So if we graph this parabola, we see that it has zeros at 0 and 1. The tangent lines to the curve have to pass through 3, 3, 3, negative 3. And my second point, you'll notice at the top of my graph is x, x squared minus x. So the first thing I need to do is take the derivative of the equation, because remember that taking the derivative of the equation is actually the slope of the tangent line. So the derivative of the graph is 2x minus 1, and that's the slope of the tangent line. But using my 2 points that I've got labeled on the graph, my slope is also y2 minus y1 over x2 minus x1. And that's where I get the expression for slope written up here as x squared minus x minus negative 3 all over x minus 3. So this is the slope of the tangent line. And remember, the derivative of 2x minus 1 is also the slope of the tangent line. So these two expressions end up being equal. To simplify these expressions being equal, I'm going to cross multiply. 2x minus 1 times x minus 3 equals x squared minus x plus 3. Do FOIL on the expression on the left. Combine the equation so it equals 0. And I get my x values of x equals 0 and 6. Now when you plug in x equals 0 back into the original parabola of y equals x squared minus x, y equals 0 as well. Plugging x equals 0 into the derivative, y prime equals negative 1. And remember, y prime is also the slope at that point. So one of the equations of the tangent line is y equals negative x. To find the second equation, I plug in the value x equals 6 into the original parabola. So 6 squared is 36 minus 6. My y value equals 30, because 36 minus 6 is 30. Take the derivative of the parabola. So into 2x minus 1, I plug in 6 which is the x value, my y prime equals 11. And remember, the derivative is also the slope. So using your equation for a line, y minus 30 equals the slope times x minus 6. Simplifying that, the other equation to the tangent line, for the tangent line, is 11x minus y minus 36. So I've answered my question of finding the tangent lines to this parabola.